Hi everybody, good morning. We can make a start. We've got a pretty action-packed, I think 45 minutes, so we'll try and fit as much in as we can. Thank you for coming out this morning. My name is Charles Feddersen. I'm a program manager in the Azure Synapse Analytics team at Microsoft, so it's been a busy week for us. So I'm really pleased to be able to come with my good friend Christian Wade here from Power BI and show you how these two technologies really fit together very, very nicely. Christian, want to do a quick intro?
Yeah, hello everyone. I'm Christian Wade. I'm a program manager in the Power BI team, and I look after enterprise features for scalability and complex models and enterprise BI in general.
Excellent.
Right.
So let's make a start here. As many of you will have seen this week, the way we think about Azure Synapse Analytics is really the evolution of Azure SQL Data Warehouse. And so if you're sitting in this room today and you're an Azure SQL Data Warehouse customer, the good news is you're going to become an Azure Synapse customer very, very quickly. And what we want to show you today is really how you can bring your Power BI that you're going to build or you may have built already and make that work as a connected service with Azure Synapse. And so when you think about the stack, what we're really going to show today, Synapse is really a combination of capabilities that brings together data integration, SQL analytics that you will frequently pair with something like Power BI, and then also Spark for big data processing into a single service for building enterprise analytics solutions. And so today we're really focusing on the SQL language over the provisioned capacity here, or provisioned form factor on the SQL runtime. And so when you think about how Synapse works, there's really two concepts here. There's the capabilities that exist within the service itself, and then there's the notion of connected services. And so we think of Power BI as a connected service, but as Christian's going to show you today, you can actually author Power BI reports directly within the Synapse Studio in the browser. And so if you're one of those end-to-end people who does everything from data integration through building SQL models and then building reports, you can now build that entirely within a single web-based UI with the correct callouts to the respective services. If you've attended a session that we've done previously on this topic, you would have seen a slide like this that talked about the modern data warehouse. And this was really a solution pattern that brought together a set of services, discrete services in Azure for building end-to-end solutions. And so for data integration, you would look at something like Data Factory. I'll take a data warehouse for doing that scalable SQL analytics. The flow and the model here does not change with Synapse, but we make it far simpler. This is how to think about it today with Azure Synapse Analytics and Power BI as that rich reporting and visualization layer at the top. So let me talk a little bit about the capabilities of SQL. As you saw in some of the keynote demos, Rohan and also John, perhaps in Jason Zanders if you were there, the performance of Synapse is simply unmatched. There's published information that shows on the two industry standard benchmarks of both TPC-H and DS that Synapse is the price performance leader for SQL analytics in the industry. We have incredibly comprehensive security built into the platform, all the way down to cell-level security of a single table at runtime of a query. And that's really important for self-service BI, where you're enabling hundreds or maybe thousands of users with Power BI or any other tool that they may have built themselves sometimes. The commonality in accessing the data is their login. And so the fact that we can secure data in the data platform right down to the most granular level, regardless of the query or the application they're running, makes Synapse a very powerful platform for self-service analytics because you no longer need to manage both application layer security for fine-grained data access and then more coarse-grained security in the platform as well. Intelligent workload management, the ability to have multiple compute pools over your data, operating over shared data. Data flexibility, I'm going to show you something pretty neat today that we've enabled with the Parquet format that really bridges that divide for personas who might be working in the Spark ecosystem and they're producing the Parquet format. And you want to report off Parquet performantly directly in your Power BI visualizations. And then for developer productivity, for those of you who have some history or experience in Visual Studio, we've also enabled the full set of SQL data tools for database projects, version control, continuous integration and deployment, unit testing, schema comparison, directly within Visual Studio as well. So if you've enjoyed the SSDT experience for SQL Server for the best part of a decade, that now exists for the SQL capabilities in Azure Synapse as well. Christian, do you want to drill into the enterprise BI capabilities?
Yeah, absolutely, Charles. So for those of you who don't know, Power BI data sets are literally based on analysis services models. And we at Microsoft, we have a rich history in enterprise BI. Analysis services is now 20 years old. And you know, we've basically been dominators in the market for a long, long time. And we have merged enterprise BI with self-service BI for a single all-inclusive platform that works for both of the workloads on the same platform. You don't need to bridge the gap between the two camps. All right, and in terms of governance, you know, we have rich auditing capabilities, both on-prem. You know, it's the same engine even in SQL Server Analysis Services and Azure Analysis Services and in Power BI. So on-prem, you can use extended events. In Azure Analysis Services, you can use Azure Diagnostic Logging, and that's coming to Power BI. And a unique area that Power BI has in terms of governance is the ability to tag Power BI artifacts and set the sensitivity levels that is the same sensitivity levels that Microsoft Office artifacts use, which means that you can have Microsoft Cloud App Security administrators have policies throughout your entire organization and protect your data. And this is a unique differentiator that we, as Microsoft, can provide. Scalability, we've just launched this week large models that takes Power BI dataset caches up to parity with Azure Analysis Services, up to 400 gigabytes of compressed data, which is many, multiple terabytes. But as we're going to show here, on top of Azure Synapse, you can use composite models and aggregations to unlock multi-petabyte data sets for really interactive analysis, just allow the users to navigate through the data and slice and dice the data. Open platform connectivity, but because the Power BI data sets are based on the analysis services technology, we opened up what we call the XMLA endpoint. That means that, you know, basically every other major BI vendor in Gartner's Magic Quadrant can now connect to a Power BI data set as though it were analysis services. Now, obviously, we are confident that any users using non-Microsoft BI visualization tools will gravitate to Power BI in the long term, and that they just need the opportunity to understand the differentiators there. But what this allows you to do is to roll out a semantic model, perhaps at a global scale. And if you've got certain pockets, certain departments of users that are still using non-Microsoft business intelligence tools, they can continue to do so, but you get to push that single version of the truth semantic model on top of your Synapse SQL pool, perhaps, to promote the single version of the truth. And application lifecycle management, as Charles said, there are tools like Schema Compare now in Visual Studio for Synapse SQL pools. We have equivalent capabilities in analysis services that will be shortly coming to Power BI. We have things like Schema Compare, check into source control, incremental deployments across environments, and we have some unique ALM capabilities in Power BI for incremental deployments across environments that we're going to launch soon as well. And everything will be fully backwards compatible, with DevOps integration pipelines for CI/CD, et cetera. And manageability. So Power BI really simplifies the management experience. Things like incremental refresh, instead of writing 1,000 lines of code, you can just fill in a simple dialogue. We run all the code for you. We generate the partitions, and we allow you to incrementally load your in-memory cache in order to meet your SLAs.
Excellent. Thanks,
Right.
Christian.
OK.
So if I drill forward here a little bit, let's go back onto here. I just want to drill into two of these pillars that I talked about in the previous slide, and they are the security and the data flexibility. I'll show you a couple of demos for each here. So with security, we think about this as a defense in depth strategy, 5 distinct categories, each with a set of capabilities to help you secure your data. So in threat protection, you've got proactive threat detection, vulnerability assessments, common 24/7 proactive services that exist across every SQL form factor in Azure. VNets and firewalls, I think, are pretty well-known entities, as is the authentication. Multi-factor authentication is also important. What I wanted to spend a little more time on is around that access control. So I talked before about native row-level and column-level security, which effectively gives you, at the intersection, cell-level security in the database engine, regardless of the application or query coming into the system. But what we've also enabled is dynamic data masking as well. Column-level security in itself will block access to that column. If a user writes a query and asks for that column and they don't have permission, it'll bounce an error back. You can't see it. But sometimes when you're building reports in Power BI, you need to hold the schema. I need a result set back. I need to see this. I need the full schema, the full set of columns, so I can create my visualization. And so with dynamic data masking based on who you are, we can mask that data, turn it into a set of X's, or there are even some system functions like email, which will take an email address and turn it into x@x.com. So you can sort of get some benefit that you can see it's an email, but you don't actually see the PII data. And this means you're getting back what you expect from the platform, but we're adhering to that sensitive data. And so let me switch in and just give you a quick demo of what this looks like in the platform, and then we'll keep going from there. Okay, so here I'm in Management Studio, and what I have two users split on each side. And the only difference between these two folks is that I have, on the left-hand side, I have an administrator. So you can see here I'm connected to SQL DWA. They have full permission on the data. And over here I'm connected to CA, which in this scenario we're saying I'm looking at data from the states of the United States. I have an analyst in California, and the only data they should be able to access is data in the state of California. And so here I'm going to go run a query for my administrator, and they're going to get back a set of data. We won't look at it, but you can tell that obviously all of the data is here. Imagine this has come down from Power BI. This is the results that they get. Now I'm in Power BI and I log in as this user, and I run exactly the same query. What I'm going to get back, and maybe a giveaway from the results that were already there, is just CA. And so Power BI obviously knows how to handle this. It can create the visualization, but it's completely built into the engine, so it doesn't matter where that comes from. Now let's take a quick look at column level security. Again, you would expect that my administrator can see everything, and this query returns successfully. However, my CA user does not have access to these columns. And so as I mentioned, that same query is actually going to generate some errors. And the only way that they can get this query to run is if they omit those columns from the query, and they go and run this query, but now you're not getting back exactly what you want. You've had to change the query between two users, and that can make some challenges in the portability of your reports and giving out the same consistent thing. And so what you can do is you can look at dynamic data masking. I really don't want this person to see sales date and sales month. For whatever reason, for the sake of demo, they're sensitive. So here comes my administrator, and I'm going to go run this. Let's go run this again. I've got sales zip marked here, actually. And we'll run this query, and you can just see it's masked. But I get a result set back. It's exactly the schema that I wanted, so I'm going to be able to populate that. But it's masking what the true value is, and so I'm protecting my sensitive data. Let me now show you the other demo that I'm going to switch back to 4. I think we are. 4? What's that one?
5.
No? Wrong button. We'll go to this one.
Okay.
Pop that guy. So the other thing that I want to show you, and this is brand new at Ignite, and we'll release a blog on this actually tomorrow, is we have enabled the Parquet format natively within Synapse as a supported format. What this means now is we can do a ton of optimizations running SQL queries directly over the Parquet format. Why does this matter? If you can store Parquet that might be produced from Spark-based systems or other data systems, maybe these are data scientists producing forecasts, and they want to go and actually surface some results, put that in a data lake, and then you want to operationalize that for your analysts very quickly. I showed yesterday in a different session, if anyone was present, how actually you can do something in Spark and immediately map that metadata into other catalogs so that you don't need to cut and paste DDL between systems as you may have once done. The other part of that problem is having very efficient access to the data. And so querying over the lake has always been one of those, well, you can query over the lake, but it's kind of slow. And so if you really want to go fast, you've got to load it into the warehouse as well. We've broken down a lot of that with our capabilities in Parquet. And I want to show you just what that looks like very quickly as well. So let me flip back to that demo that I have right here. We'll go over to this guy. And so here, I'm not going to run this, but you can see I've got an external table. I've got a bunch of columns based on New York City taxi data. And here you'll see some syntax, which is not what you'd be familiar with creating tables in SQL Server. But I've got a data source, which shows sort of where I'm going, this sort of infers the fact, yeah, I'm connecting to Parquet directly stored in my data lake. And so really what I'm doing here, this is the schema on read, where I'm taking an external table and I'm saying this is where my data is and it conforms to this schema. And now that I have a table entity, I can obviously run SQL on that. And so now I'm going to pretend I'm not, I'll show you I'm not cheating. Let's go run drop clean buffers. Now let's go run this. I am querying from SQL Parquet in the data lake. And we expect something to come back pretty quickly. Let's go do another one. Let's go do distinct vendor IDs directly across Parquet in the data lake from SQL. The critical thing here is I have not loaded this data. That notion of loading, integration services, bulk inserts, inserting into databases, that has not happened as part of this flow. This is data that's been produced by something, put in the data lake with a schema on top, and now I can drive through SQL, through my data warehouse. My Power BI people are connecting to SQL. I'm driving interactive speed analytics directly over the data lake using the SQL interface. And so this becomes very, very powerful for some of these scenarios of doing analytics directly over the lake. So let me switch back now, and we'll keep moving at our frenetic pace. Back to you, Mr. Christian.
Thank you very much, Charles. So just to put things in context, we have an in-memory, column-oriented storage capability that unlocks sizable data sets for interactive analysis. You know, BI users expect fast queries. We have, in my opinion, the fastest BI engine on the planet. You know, we compress perhaps multiple terabytes into, perhaps 100 gigabyte model, and we unlock these massive data sets for interactive analysis. And that's the in-memory technology, but we also support, I'll jump straight down to DirectQuery. We also support DirectQuery, where the Power BI data set acts as a kind of virtual pass-through layer. So as users interact with visuals in Power BI, Power BI will generate SQL queries to the Synapse SQL pool. All right, and up until last summer, you had to pick one or the other. The whole model was either in memory or the whole model was DirectQuery. So it was great if you could easily fit all of the data into memory, but even with our compression ratios, if you've got many, perhaps petabytes of data, you're going to need a lot of memory, and you're going to have a management overhead to try and replicate all of that data into memory, right? So you could put DirectQuery on top of a massive data set like that, but then the performance, there might be some areas where you just want to tune the performance with the in-memory engine for certain queries, and you weren't able to do that because the whole Power BI data set was either in memory or DirectQuery. So last summer, we introduced the concept of composite models, where you can pick and choose which tables to cache into memory, get much better bang for your buck in terms of memory consumption. And we also introduced this concept of a dual storage mode, where we have a table that can be either in memory or DirectQuery, depending on what is the most efficient, right? So if all the data is going to come from in memory for a query, it will just all come from in memory. But if it needs to revert to DirectQuery, it's better to push, logic down to the Synapse SQL pool, because it's just more efficient to push, some group by logic and things like that. So we have the full capability here, and it's very flexible, and the engine, you can configure it so that the engine decides when to switch from in-memory to DirectQuery. Okay?
Why don't you show us?
Yeah. Okay, actually, I think I've got a couple more slides here. So actually, so let's say the model was either in memory or DirectQuery, and then we can pick and choose. I'll just run through this really quick. So you can pick and choose which tables to cache into memory. And then let's say the sales table has maybe 26 billion rows. What you can do is create a sales ag table that in this case is the non-empty cross-join of date ID and geography ID, which is going to have potentially a couple of million. It's going to be super cheap to cache. It will just run in, sub-second to refresh that into memory, right? And then you configure the engine so that you tell the Power BI engine, which is actually the analysis services engine, that any DAX queries that are generated from users interacting with reports. So this is a DAX query that's submitted to the Power BI datasets. Any DAX queries that in this case are asking for sum of sales amount, it knows the query, the user knows nothing about the aggregation table. It just asks for the sum of sales amount. And then the engine will figure out that it can actually answer that query from the in-memory cache hidden the cell's ag table, which is super fast, right? And a lot of BI queries are aggregated, so you can get a very high cache hit ratio. And if the user then maybe breaks it out, sum of cells by customer name, customer is one of the tables that is not at the granularity that can hit the in-memory cache. It will on the fly revert to DirectQuery. The date table has flipped back and forth. So a moment ago it was blue, now it's white because it's a dual table. So now it's pushing that sum group by down to the source, which is much more efficient, right? Make sense? Okay? All right. So I'm going to give you a quick demo of this now. So here I have a Power BI data set. These tables are actually from the TPC-DS data set that is used for performance benchmarking, which you've probably seen in many of the marketing slides. So this store sales table has 26 billion rows of data. And before we get to the Power BI report bit, I'm going to show you how the queries work themselves. So as users interact with reports in Power BI, as I said, these DAX queries are submitted to the Power BI dataset, right? So I'm going to run this one. This one is asking for the sum of store sales by year. And it took about 8 seconds, which isn't bad considering there's 26 billion rows. And if we look here at the SQL query that was generated, you can see that it did indeed submit a direct query or a SQL query down to the Synapse SQL pool, and it's referring to the 26 billion row table. All right?
26 billion rows in 8 seconds off Synapse.
Yes, exactly.
I still think that's pretty good.
It's not bad, but we like to do a little bit better if we can.
All right.
So let's see how far we can go with
going.
this. It's a Materialized View. But as you may know, the Synapse SQL pool can actually hit the Materialized View. Even if you submit a query against the base fact table, it can figure out that it can actually return that data from the Materialized View and still give you the improved performance. But in this case, I'm explicitly referring to the Materialized View. The query that's generated for this table is explicitly referring to the Materialized View. So what I'm going to do, I'm going to come into the Manage Aggregations dialog. And so here we have the columns in the aggregation table, right? So this is effectively the sum of sales grouped by store ID and date ID. And so this is the sales price column, which is a sum aggregation based on the store sales table and the sales price column, right? And so that's all I have to do. There are lots of different aggregation functions, lots of DAX aggregation functions that can hit these in-memory cache. Averages can, take a sum divided by a count, even a distinct count. I'm not going to go there right now, but you can even get a distinct count to hit the ag. Believe it or not, it's actually possible. So you get good coverage of all of the DAX functions, and you can have complex calculations. A sum divided by a count divided by the percent of parent. All of those get folded down into individual subqueries that are then evaluated to see whether they can hit the aggregation table, right? Okay, so I've set this up. So now we're going to run the same query again. And let's see what happens. So we would get the same results back, all right? So there's the same results. And this time we got an aggregate rewrite attempt match found. And if we look at the query this time, this is actually referring to the Materialized View, all right? So, and it went down from about 8 seconds to just under 2.5 seconds, which is a significant improvement, right? So we're getting the, and the really good thing about this kind of architecture, I haven't even used the in-memory engine in Power BI yet. The whole model is still in DirectQuery, right? So this is really good for like near real-time BI requirements where the data might change in the fact table and you want it reflected immediately in the aggregated at the aggregated level, because the materialized view is going to automatically update, right?
Yeah, that's right. So one of the guarantees that Synapse makes is the transactional consistency of data between tables and materialized views you create in the database. And so if you create a materialized view that references one or multiple tables in a join and you load data into those tables, we will apply just that delta to the materialized view as well, so that whether you query the table or the view explicitly, you will never get different results. We guarantee that consistency. And so in this model, we may have just loaded tables into Synapse, put more data into them, and the next query that Christian runs, even though it's a materialized view, will be up to the latest data that was loaded into the database.
Yeah, so that's really cool. So we've got this under 2.5 seconds over a 26 billion row table.
2.5, under 2.5.
So that's pretty good. But we want to go further. Let's go a little bit further. What can we do? Let's go ahead and cache this aggregation table into memory. Again, we have this composite models feature. We can pick and choose which tables to cache into memory. This table is tiny compared to the 26 billion row one, right? It's easy to cache into memory if we want, right? So I'm going to come into the storage mode, which, as you can see at the moment, this is the storage mode here. And as you can see, it's direct query. And so all of these tables are direct query right now. So I'm going to go ahead and say, I want this one to be import. And at this point, the Power BI Desktop has figured out that it would be a good idea to go ahead and make date and store dual, right? And these are dimension tables. They're normally very cheap to cache. Normally, like 2% of the average consumption is taken up by dimension tables. There's a lot less data in them. The cardinality is a lot better. So that's fine. We can go ahead and make date and store dual, right? And I actually have one prepared so that we don't need to wait a few seconds for that to run. So as you can see here, the aggregation table is import, date and store are dual, and the big 26 billion row fact table is still direct query, all right? So now I'm going to switch over to the other model that is set up like that. I'm going to re-enable server timings, and we're going to run this query again. Right, and we would get exactly the same results back. And let's see how fast this took. Is this accurate? This is actually 0 milliseconds. Is that even physically possible? Yes, because it's round to 0 milliseconds over a 26 billion row table. Right, that's how we roll. The milliseconds as a unit of measure is not even fast enough for us. Right, we deal in microseconds. You know, if I'm like 3 microseconds late for a meeting, it's a pretty big deal for me. Right, so 0 milliseconds.
Sure.
All right. Thank you very much. Thank you very much. That's how we roll. All right, and this isn't even a T-SQL query. This is actually a query against the analysis services engine, and we got a match. So that is really, really cool.
But what's critical here as well is the transparency to the end user. Like to the end user's experience building their visualizations, you've actually not changed anything. We've masked the whole thing.
Exactly.
Power BI has the smarts to understand whether it can hit cache or go through the dual, the composite model, all the way through to the raw data in the warehouse.
And it's completely abstracted from the end user, right? The end user of Power BI barely writes any queries. They barely know what SQL stands for, right? They just want to clicky, draggy, droppy.
Give them a little bit of credit, man.
All right, so, okay, the data engineer, there's lots of different personas, right? You got, I'm talking about the end user, the real end user that is the bulk of the user. Obviously, you've got data engineers that use Power BI, but there are many end users. They just want to click and drag and drop and create beautiful reports without even having to write any queries. So we're going to unlock these massive data sets in the Synapse SQL pool through Power BI for the masses, all right? Now, what happens? You may ask, what happens if we run a query that doesn't hit the in-memory cache? So I'm going to run this query. And so this query is actually asking for the sum of sales by customer birth year. And if we look back here at the model, you can see that customer is not at the granularity that can hit the aggregation table, right? It doesn't have a relationship to the aggregation table. We could have a much wider aggregation table than this quite easily, quite comfortably, but for the purpose of this demo, the customer dimension table doesn't relate to the aggregation table, so it's not at the granularity that can hit the aggregated cache. So what's going to happen? Is the user going to have to run SQL, run some queries or run a different report? No, it's all completely abstracted. So it just takes a little bit longer in this case. It took 42 seconds, or let's see, about 42 seconds for the storage engine query. And you can see here that we did not get an aggregation hit. All right, and you can see here that the SQL query, it reverted to DirectQuery on the fly, and the SQL query is now referring to the 26 billion row fact table. But Charles, is there anything we could do potentially to improve these scenarios? You know, if you think about Power BI, the vast majority of queries are at the aggregated level, right? 95% are going to hit the aggregated cache and you're going to be fine. But what happens if, for whatever reason, the user really has a requirement to drill down to the detailed level? What's going to happen? Is there anything we can do about this?
There is, actually. So what we see with Power BI is there is a lot of repetitive queries that come down. One of the fantastic features within Synapse is the result set caching, which will automatically determine that a query has been repeated, the same query text has come down. We have the smarts to know that the underlying data has not been changed. So that same query, it's going to be deterministic. It would yield exactly the same results. And so we can cache that result set completely implicitly. The user doesn't need to know about it. And so they'll just come back and hit it with Power BI, or maybe someone else runs the same query only 5 seconds later. It's 9 in the morning, they've got their coffee, and they're running their dashboards for the day. And that second user and every subsequent user is going to have a vastly different experience just because of the multiple caching layers in the platform. So Christian, why don't you go run it again?
You mean like right now?
Just right now, sir. Run it again. I hope.
Sure?
I hope. Yeah.
All right. Whoa,
Cool.
154 milliseconds. That was impressive, Charles.
So very subtly, all I did under the covers about 3 minutes ago was enable result set caching on Synapse with a single SQL statement. And therefore, when Christian sent the same query down immediately, we knew what that result was. We just pulled it directly from the cache and we returned it in approximately 200 milliseconds. Yeah. So this is something that can give you tremendous benefit for these dashboards where often you're not doing a whole lot of filtering, you're just sending the same stuff down. You only need to run that query or execute that query once in between data modification.
Yeah, this is a really big deal for BI and this direct query model, because if you think about it, all of these queries are generated by Power BI. There's a user interacting, clicking a slicer, and it's going to generate a T-SQL query. Well, guess what? The next time a user clicks on the same slicer, the same SQL query is going to get generated with exactly the same query text. It's a machine-generated query. So you're going to get really good responses from this result set cache feature. So this is really cool. Yeah.
Cool. So maybe I should go and explain a little bit about how this is actually working. So Christian walked you through the caching layers that we have within Power BI, but that's only part of the story. When you start to look in Synapse, we also offer multiple levels, and this is where the economics of the platform really start to shine. You know, if you want, you could cache all of your data in memory. It's going to be incredibly expensive, and you're not going to hit all of your data that frequently. By building Power BI and Synapse together, you get this multi-tier caching where you get the cloud economics of storage in Azure Storage for storing the vast amounts of your data. It's fully accessible to you in the distributed SQL engine within Synapse. But we can aggregate that data up through multiple tiers, as Christian has shown, and the result set cache. So the way these look like in Synapse comes from the bottom up with massively I/O-optimized storage. We have the most comprehensive set of data structures for tables of any cloud data warehouse. Hash partitioning, table partitioning, secondary indexes are all built in, and the cost-based optimizer will automatically leverage these. And I'll show you in a second how the optimizer can even leverage materialized views without any explicit instruction from the user. And so what these materialized views do, as I described, enable you to join tables. Joining tables, particularly at scale, is a very expensive operation. But the one we just showed you was a materialized view where we had joined 26 billion records from one table to 65 million records of another table. And although Synapse is very efficient and can do that relatively quickly, you're still going to be looking at seconds or minutes to go and do that. And so if we can do that once with a materialized view, automatically have users hit that join when they submit a query against the tables, and I'll show you that in a second, that's very powerful for just spending less compute to realize the same results. We built what we called an SSD-backed adaptive cache as well. So all of your data in Synapse sets on cloud storage, but to get that screaming fast performance, we flow it up through multiple levels of cache closer and local to the nodes. So SQL has always had its object pool where we would cache in memory. If anyone's ever started up SQL Server cold, for example, and looked at perfmon, that first query when the I/O flies off the charts and you watch your memory consumption slowly increase as we start caching. And then that second query is screaming hot. The caching is implicit in the user's query actions. We extended that cache to SSD as well without any complexity for the user. We just cache more data locally and the platform handles all of it for you. Then, of course, as I mentioned, we have in-memory as well. So if my most frequently used data, the data that I need all the time, will automatically keep that in the main memory of the system, and then slightly less used data sits back in SSD, but the authoritative store in all of your data is always triplicated and even geo-redundant in the primary cloud storage of Azure Synapse. And then finally, what we just showed is the result set cache. And so this stack of features and capabilities really works completely automatically for the user. The queries that Christian showed basically submitted from the yellow box at the top. They determined they couldn't get an in-memory hit on the cache. It switched to dual mode and sent a direct query. The first queries did not have a result set cache hit, so then we looked in memory. We actually did have it in memory, but had we not even had cache populated in Synapse, we would have checked the SSD. Materialized view actually happens further up the stack. That's in the optimization phase. And then ultimately, we would have gone all the way down to cloud storage and flowed that data back up. But then after that, just simply in that query action, we populated all of those caches with the data and the result set cache, so your subsequent actions were screaming really fast. Cool.
So the end user knows nothing about this.
No, right? It's a secret.
Yeah,
don't tell
them. The user, do you mind if I just quickly show the user experience?
Sure.
Because I've actually got something really special to show you. So guess where I am? I'm in Synapse Studio, right? And you'll notice I have not only SQL scripts, not only Jupyter notebooks, I also have Power BI artifacts.
Yeah.
Why? Because
and you're wearing the hoodie.
And I'm wearing the hoodie. Why? Because we're in the Power BI group. We heard about this Synapse party you guys were going to have, and we said we like to party. We will gladly build deep integration of Power BI artifacts into Synapse Studio. So this is exactly what we've got. We've also got Power BI artifacts down here, and all I have to do to create a new report, I say new report, I select the TPCDS data set that we just optimized and I've already uploaded to the Synapse workspace. I say create, and now I get full fidelity report authoring right here in the Synapse environment. So let's go ahead and take store sales. And so this sales count measure gives us the count of the rows in the store sales table. At this point, I say, oh, let's casually drag this onto the canvas and see how many rows we have in here. We already know how many rows are in here, 26 billion, right? But it's just nothing. It comes back in instant response times, instant gratification over 26 billion rows of data. The user has no idea. It's just like beautiful. So then we'll go ahead and take sales, and let's break out sales by date. We'll make it nice and big. We'll make it a bar chart. And let's break this out by the, you want item, store, customer. Let's go with store. Let's bring this in. And I just get clicky, clicky, draggy, droppy, instant gratification over 26 billion rows, many terabytes of data right here in Synapse Studio. I'm the data engineer. I get to save this report, and my users can all consume it. Beautiful.
It's fantastic.
All right.
All right. Now, there's a couple of final things that I just want to talk about here, just to back some of this up. Earlier this year, an analyst firm went and actually ran the two industry standard benchmarks, which are TPCH and TPCDS. And the results they yielded is that Synapse is the fastest or most price-performant platform of any cloud data warehouse on the market. This is publicly available data. I abbreviated into two charts here. But if you're interested, these are actually both about 30-page PDFs that just go through the full methodology of how these tests were run. And so you can see for yourself exactly what they did, how they ran it, and look at this. But this platform is really the most price-performant cloud data warehouse according to these benchmarks. And we've tried to show you today how you can leverage not just that performance in Synapse, but then also bringing Power BI and those features to it to create a really seamless and interactive and responsive experience for your end users. I touched on a little bit of these, but I just wanted to quickly touch on the full complete set here. So obviously Synapse is elastic. You can scale out. You can pause and resume your capacity. Columnar storage is just table stakes. At Ignite, we GA'd explicitly ordered columnar. So if you seek on that column, if you've got where clauses, that's going to be incredibly performant because we can prune so much I/O away. Table partitioning, as you've noted in SQL, is there. Secondary non-clustered indexes. If you need to seek on columns that are not ordered in the column store, the optimizer will automatically revert to that index, and that's going to give you a massive performance boost as well. Hash distributions is how we separate and distribute this data. Materialized views, I'm going to show you a quick demo in a second, and then the result set cache we've talked about already. The combination of these elements in a single platform is unique amongst any cloud data warehouse today. And these are the features, when combined, that enable you to deliver the level of performance that we've shown today. We didn't walk through every single one of them in the demos, but under the covers, these were all lighting up to enable the scenario that we showed. So let me talk a little bit about materialized views. The thing about materialized views, and some other platforms refer to them as aggregate join indexes, is they enable you to remove both the cost and aggregation from running the same query repetitively. So consider this materialized views that I've got here, and I'll point you to a couple of things. First of all, I've got joins in the view. So there's smarts in the platform that even though I've materialized a result set that has joins between tables, if I modify one of those tables, we could still pull that change through consistently, even though it's joined to other tables. And then it also has aggregates. So now today a materialized view requires requires aggregates to be in the definition. The joins are optional. But what we showed there was the ability that when I ran a query, I would just hit this materialized view automatically. And so let me just quickly show you, at the end of this, you'll end up with a single object called store sales summary. And the thing here about the optimizer is you're just sending queries to Synapse, and it's going to make a decision whether it wants to hit the tables with its columnar, ordered columnar, partitioning, and secondary indexes, or if there's a cheaper, more efficient way to execute the query. And so let me just give you a quick demonstration of that, and I'll show you exactly what I'm talking about. Switch back over to Management Studio here. So here you can see the exact same materialized view that I just showed you. And so it's called MVW Store Sales Summary, and it's a join between these three tables, Sales 2, Customer, and Store. Yeah. Let me go run a query here. Let me go run a basic aggregation. I'm looking for the sum of the two columns, but there's no reference to my materialized view at all. I'm just querying tables. Imagine Power BI just sent this query down. And so I can show you the execution plan here, and mouse over this. And you can see here that it's decided that I can hit the materialized view. I have no expectation of my end user to know that this query will run faster on the view. My users know what tables they have. Hopefully, maybe there's a data dictionary, they understand them. The platform will automatically handle that matching. But that was kind of an easy one. Maybe I cheated a bit because I just did sums of that exact materialized view. It's sort of defined up here already. What if I go do something completely different? Give me a count distinct, not even referenced in the materialized view. We'll go do exactly the same thing. We'll go, oops, get it again. Same thing. So the optimizer is super, super smart. It still knows that even if I want to do a count distinct, this materialized view has been defined in a way that it's maintained the uniqueness of this value. And so I'm just going to send a count distinct down on this materialized view that actually only has 230 million rows in it instead of the 26 billion. And that's going to need a lot less compute, be far cheaper and faster to run. So that's what the materialized view looks like. Now let me show you a quick demo. I think we're coming up on time pretty quick, about result set caching. So I'm a little bit traditional. And so one of the things that I always do is switch out to the old command prompt, and we'll just pop this. It's going to be super small, but I'll zoom in a sec. What I want to go do is show the true impact. When we ran result set caching, you just sort of ran one query, right, and it came back fast. Yeah. Let me show you what this experience would look like actually for end users. And so I'm going to go run a query here, and this query is going to run repetitively, and the result set cache is on. This first one takes about 6 seconds. It's super CPU intensive, and I designed it that way. Uh-oh. But then, if you're running this many queries, your battery's obviously going to run out pretty soon. But after that first query ran, we went into result set cache mode. And so every time that query has come down, we just punch them back in under a second. And so for all of those users, you could imagine massive enterprises where hundreds or thousands of concurrent users are starting to hit the platform. Once that first query has been run, they're going to go hit the results set cache and have a really, really nice experience. And only when they bring a new query that we've not seen since the last data change, they're going to get unlucky for a few seconds, and then everyone else is going to ride on that as well. So results set caching is incredibly powerful for enabling this interactive analytics at scale with Power BI and all of the DirectQuery capabilities directly on top of it. So with that, I think we're largely on time. We have 6 seconds left. If there are any final questions, could we take the question at the mic, please, just so everyone can hear it? We'd love to take a few Q&A.
How do you ensure the freshness of the data with the result set cache? How do you avoid stillness?
So it's all built in. So the system understands that there's data, the results set cache is referencing it. So when we change the underlying table, we'll automatically evict the results set cache, and next time you run it, it'll freshen up.
And one last question.
Sure.
Can you partition a materialized view?
No, not today. It's a great question. Thank you. So we're on time. Thank you, everybody. And to the gentleman that actually just asked the question, congratulations for the first question. We do have a coveted Azure Synapse hoodie for you. So we appreciate your Q&A. Sorry for everyone else who didn't ask a question. Thank you very much.
All right.